A wasp paralyzes a spider with a single sting. Fast, surgical, obvious. A scorpion drops a mouse in seconds. A cobra puts down a buffalo before it even knows it was bitten. Every poison in nature kills fast. Every poison in nature is loud. And then there's the one that took 500 years. 100 million people, gone. No fangs, no venom glands, just a leaf. And somehow, we lined up for it. The plant has no army, no money, no politics, no brain, just chemistry, just one molecule. And that molecule knows how to speak the language your brain understands best. Nicotine. Start with the plant. Tobacco didn't evolve to entertain humans. It evolved to stay alive. A plant can't run. It has no teeth, no claws, no voice. Every leaf is a soft target for any insect that wants a bite. So over millions of years, tobacco built a weapon. A chemical one, synthesized in the roots, pumped upward into the youngest, softest leaves. The leaves an insect is most likely to chew on are the ones loaded with the most nicotine. That's not random. That's engineering. When a beetle starts eating, nicotine floods into its nervous system. It locks onto the receptors that control its muscles, and it doesn't let go. The signals run non-stop. The muscles contract without stopping. The beetle convulses, falls off the leaf, and dies. The system is flawless. It has worked for millions of years. But tobacco ran into a problem it could not have predicted, a species that liked the molecule on purpose. The Maya were smoking tobacco 2,500 years ago, carved into stone, in ritual, in medicine, in diplomacy. When Columbus landed in 1492, locals handed him a bundle of dried tobacco leaves as a gift. He threw them overboard. He had no idea what they were. His crew was more curious. The habit came back to Europe with them. A French diplomat named Jean Nicot sent tobacco to Queen Catherine de' Medici in 1560 as a treatment for migraines. The court went wild for it. The molecule was named after him, nicotine, from a man who thought he was sending medicine. Now the part that matters. What happens inside you? You inhale. The molecule crosses from your lungs into your blood, from your blood into your brain. 3 barriers, including the strongest one your body has. The blood-brain barrier exists to keep almost everything out. Drugs, toxins, foreign molecules. Nicotine walks through it like it's not there. The shape is right, the charge is right. The brain doesn't even notice. 7 seconds. That's how long it takes. Less time than it takes you to fully exhale the smoke. Heroin, injected directly, takes about the same. That is not a coincidence. The speed at which a molecule reaches your brain is one of the biggest predictors of how addictive it will be. Nicotine is built for speed. Inside your brain, nicotine is looking for something specific, receptors, tiny molecular doors built into the surface of your neurons. Normally, those doors are opened by a neurotransmitter called acetylcholine. It's the molecule your brain uses to manage attention, memory, alertness. Nicotine is shaped almost exactly like acetylcholine, close enough to fit the lock, different enough to break the rules. Acetylcholine opens the door and leaves. Quick visit, normal traffic. Nicotine opens the door and stays. The most common version of this receptor in your brain has a name. Researchers call it alpha, 4-beta-2. More than 80% of nicotine's effect runs through this one receptor. Attention, focus, mood, memory. And one thing more important than all of them. Dopamine. You've heard of it. You've probably heard it called the pleasure chemical. That's wrong. Dopamine isn't pleasure. Dopamine is a label your brain puts on things that matter. When your ancestors found food after days of hunger, dopamine spiked. Not because food felt good, because the brain was marking the moment. Remember this. Do it again. Survive. Nicotine hijacks that exact system. It hits a small region called the ventral tegmental area, roughly the size of your fingernail, and it tells the dopamine neurons to fire. The dopamine spike from a single cigarette is comparable to cocaine. Different mechanism, similar magnitude. Your brain logs it. Something important just happened. Remember this. Do it again. But here's where it gets strange. In the 1990s, a neuroscientist named Wolfram Schultz was studying dopamine in monkeys. He gave them juice as a reward. The dopamine neurons fired when the juice arrived. Expected. Then he started flashing a light just before the juice. A signal. A heads up. After a while, the dopamine neurons stopped firing when the juice arrived. They started firing when the light came on. The reward had moved. From the thing itself to the anticipation of the thing. This is what happens to a smoker. After a few weeks, the dopamine doesn't come from the nicotine. It comes from the lighter in your pocket. The smell of smoke, the break at work, the first sip of coffee, the phone in your hand. Your brain wired the entire world into the trap. The real question scientists wanted to answer was whether you could remove the trap from the molecule, whether the addiction lived in the chemical or in one specific receptor. At the Institut Pasteur in Paris in the late 1990s, researchers used genetic engineering to create mice with no beta 2 receptors. Everything else, normal. Just that one piece, missing. They gave the mice access to nicotine. The mice didn't care. No reward, no habit, no addiction. Then they restored the receptor, but only in the ventral tegmental area, one tiny region. The addiction came back, just like that. The trap isn't the molecule, the trap is the lock. Now, the part nobody likes hearing. When you flood those receptors over and over, your brain adapts. It dampens its own response. The new normal includes nicotine. Without it, things feel wrong. Not bad, just wrong. Flat, gray. This is why quitting is brutal. You aren't reaching for pleasure. You're reaching for baseline. A smoker doesn't smoke to feel good. A smoker smokes to stop feeling bad. Those are completely different things. And the second one is much, much harder to escape. Your brain rewrote its own definition of normal and then locked the door. And here is what almost nobody says out loud. The same molecule that traps you may also be one of the most promising therapeutic compounds we have. Not the smoke, the molecule, clean, alone, in the right dose. In 1984, an American neuroscientist named Paul Newhouse gave small doses of nicotine to people with Alzheimer's. Their attention improved, their processing speed improved, quietly. In a small study, then the epidemiologist noticed something else. Smokers get Parkinson's disease far less often than non-smokers, statistically, repeatedly across countries. Parkinson's kills dopamine neurons. Nicotine, hitting nicotinic receptors, protects those neurons. It slows the damage. There are clinical trials running right now. The same lock that gets exploited can also be used to keep the door from rotting off its hinges. The molecule is dual. The molecule was always dual. So step back, 500 years. A leaf from one species, growing on one continent, wandered onto a ship in 1492. It became the most widespread psychoactive substance in human history, not because people were weak, not because they didn't know better, because the molecule speaks the language your brain trusts most, the language of importance, of necessity, of remember this. And your brain listens. Every single time. That is the trade. A plant with no nervous system designed a key. The key fit a lock inside the most complex machine in the known universe. And that machine could not tell the difference. For 500 years, the score has been 1-0. Plant. But for the first time, we can see exactly how the key turns, which receptor opens, which neurons fire, which patterns rewrite themselves. We can build molecules that copy the useful parts. Without the trap, we're starting to. The plant won 500 years in a row. It did not see this coming. Because the plant has no brain. We do. The molecule isn't good or evil. The question was never about the molecule. The question was always about who is holding it.